Hi, today we will be learning a purely capacitive circuit and the current developed in the circuit. Here you have a purely capacitive circuit. It is consisting of a capacitor connected across an alternating source of voltage. A capacitor is a device that stores electrostatic energy. It stores charges. Now this capacitor can be connected to a DC source or it can be connected to an AC source. When you connect a capacitor to a DC source, then in a moment the capacitor gets charged and it develops certain potential. Due to that, it opposes any further flow of current through the circuit. So, after charging the capacitor in a DC circuit, the flow of current ceases. Now, in an AC circuit, so in first quarter of the flow of charge, quarter means 1/4 of one time period, the energy of this external alternating voltage source is consumed by capacitor while charging. Now in second quarter, means second 1/4 of time period, this capacitor gets discharged and so its energy, capacitor's energy is lost. And in whole time period, it takes place 2 times. So charges go on moving, flowing through the circuit. Current does not cease. Only capacitor regulates the current. It reduces the current, but flow of current cannot be ceased in a capacitive circuit, which is connected to a alternating voltage source. So let at any time t, charge Q is flowing through the capacitor at any time t. So we know that the capacitance of a capacitor C is equal to Q coulomb upon V volt, and from here we can find instantaneous voltage in terms of Q and C. This is equal to Q by C. So this is your voltage and the voltage supplied by alternating source, that is your given V is equal to Vm sin omega t. So from 1 and 2, you can find that Q upon C is equal to Vm sin omega t. And here we are intended to find current, instantaneous current. We have been given voltage and we need to find instantaneous current. And current is rate of change of discharge. dq by dt is called current. Therefore, let me first of all find Q. Q is equal to CVm sin omega t. And now, on differentiating this equation 3, with respect to time, then we can get instantaneous current because dq upon dt is your current I. So here we are differentiating this equation. This is equal to your d CVm sin omega t by dt. Therefore, I becomes equal to So let me take out all the constant terms outside the differentiation of the equation, because constant cannot be differentiated. Here you have differentiation of sine omega t, and it can be differentiated with respect to d omega t only. So multiplying and dividing the equation with d omega t, you will get this. And there is no change in the value, because you can cancel d omega t from numerator and denominator. Therefore, I is equal to CVM, and here when you will differentiate this term, you will get omega. So CVM omega, and this is your cos omega t. Now, you know sine 90 degree plus theta, that is omega t, is equal to cos theta, cos omega t. So in place of cos omega t, you can write this. So I is equal to Vm, and here it is in numerator, omega c is in numerator. You can bring it in denominator in this way. So it is 1 upon omega c. And here you have sine omega t plus pi by 2. Instead of 90 degree, I have written pi by 2. And this implies that I, instantaneous current, is equal to voltage amplitude divided by xc sine omega t plus pi by 2. Here xc is called capacitive reactance. Therefore, I becomes equal to current amplitude Im sine omega t plus pi by 2, where current amplitude is given by Vm, voltage amplitude, divided by capacitive reactance. So this is just similar to Ohm's law, because in Ohm's law I is equal to V by R. So here capacitive reactance will be serving as resistance. It will oppose any flow of charges through this capacitive circuit. So capacitive reactance is working as a resistor in this circuit, and it has the same unit. Unit of Xc is equal to ohm. So you have two equations. You were given instantaneous voltage, which is equal to Vm sine omega t, and you obtain instantaneous current, which is equal to Im sine omega t plus pi by 2. This is why I have converted cos omega t in terms of sine omega t plus pi by 2, so that we can compare the phases of instantaneous voltage and instantaneous current. Now, you have instantaneous voltage in terms of sine and instantaneous current also in terms of sine. So you can compare the angles now, and you can find that the phase difference between instantaneous current and instantaneous voltage, you can minus this value from this one. So omega t plus pi by 2 minus omega t, and here you have pi by 2. So a phase difference of pi by 2 is there in between instantaneous current and instantaneous voltage. And you can see that current is leading by pi by 2. Instantaneous current is leading instantaneous voltage by pi by 2. So let me show you the diagram of instantaneous voltage and instantaneous current versus omega t. This is your omega t. You have given two equations. In a capacitive circuit, purely capacitive circuit, voltage is given this one, and you obtained current, instantaneous current, which is equal to Im sine omega t plus pi by 2. Now here you can see that phase difference is of pi by 2. So firstly we will be drawing voltage versus omega t graph. Now when omega t, this omega t is taken 0, you know that sine 0 is equal to 0, then voltage becomes equal to 0. So for 0 value of omega t, your voltage is 0. Here you have one value. Now when omega t is pi by 2, sine pi by 2, here sine pi by 2 is equal to 1. So V becomes equal to Vm only. Here in diagram you can see at pi by 2, when you draw a perpendicular line and at Vm you draw a perpendicular line, you get a point here. And this is how I plotted each and every point on this diagram. Then I draw a curve from a free hand through all these plotted points, and I get this kind of curve. So you can also draw current versus omega t graph. So in this equation, now in equation 2, second equation, when you put omega t equal to 0, here it is 0, then it is remained sine pi by 2 only. Sine pi by 2 is equal to 1. So at 0 omega t, I becomes Im. Here you have current amplitude at this value. So first point for I versus omega t graph is obtained here. Similarly, you can plot all the points, and you can draw a I versus omega t curve which is passing through these plotted points. Now you can see that when voltage is 0, current is highest. It is not like a purely resistive circuit in which when current is maximum, then voltage also is maximum. Here in this case, you have when voltage is 0, current is highest. Now you can see here, when in this data table also, when voltage is maximum, it becomes voltage amplitude, then current becomes 0. So this is your purely capacitive circuit. You have drawn a V versus omega t or time period graph for one complete time period. Now this graph can be divided into 4 equal parts. You have here one part, another part, third part, and this is last part. And all the value taken above the x-axis is taken as positive. So you can see current is along positive direction in this graph. Voltage also is in positive direction. So P power, which is equal to product of I and V. So I is positive here, V also is positive. So power comes positive. Power can be shown by this curve. Power is positive. But in second quarter, second 1/4 of the time period, you can see that current is negative. One value is negative, minus I, and voltage is your positive. So product remains a negative quantity. So now, in second quarter, power will be represented in negative direction. So what does this mean? When power is positive, then power actually is supplied by alternating voltage source to the capacitor. But in second quadrant, the power is consumed from the capacitor. So now power is given by a capacitor. Now in third quadrant you can see both this is your potential and this is your current. Both are along negative direction. Both are negative. So minus I into minus V, minus minus it becomes plus. So in third quadrant, power becomes positive. So let me draw all these things with another color because it is mixed totally. Okay. So I am drawing all these things with green color. Here power is positive. Here plus and minus makes power negative. And 2 negative. Current is negative in third quadrant, third quarter. Minus I into minus V because both are in negative direction. So power becomes positive. Minus minus plus. So it is your in positive direction. And finally in fourth quarter, a minus of your voltage and plus of your current makes the power consumption negative. Now positive power consumption means power supplied by alternating voltage source to capacitor. And negative power consumption means power of the capacitor is consumed by the circuit. So in first quadrant and third quadrant, power is supplied by the source. But in second quarter and fourth quarter, power is supplied by the capacitor itself. So what is the power supplied by a capacitor? What is power consumed by a capacitor while the flow of an alternating current? Let us find analytically. We know that power is equal to IV and here I is equal to Im sin omega t plus pi by 2 and your V is equal to Vm sin omega t. So this is your power. So let us simplify this. Im, Vm, these constants. And sin 90 plus theta is your cos theta. Cos omega t and this is your sin omega t. So for simplification, I am multiplying the term with 1 by 2 and then 2. So this is changed into Im, Vm divided by 2 and 2 cos theta sin theta is sin 2 theta only. Sin 2 omega t. This is your power. So for average power in one time period, for average power, this is your average power. Constant terms cannot be further diminished or averaged. So let me take the average terms outside. And let me find the average of sine 2 omega t. We know that value of any sine theta varies from -1 to +1, and the average of these two is equal to -1 plus 1 by 2, and it becomes equal to 0. So sine theta is actually, average of sine theta is 0. Average of sine theta is your 0. Therefore, average power in a capacitive circuit in one complete time period. This is your average power consumption in one time period is equal to 0. So in an AC circuit, if we are to resist alternating current, so instead of using any resistor, we use either an inductor or a capacitor, because these provides resistance to current without consumption of any power.